So here's a fun thought experiment for you. How exactly would you write a speeding ticket for a robot? I know it sounds like the start of a bad joke, but as AI starts to show up in really serious places, like on company boards, it's a question we actually have to answer. And a really fascinating paper by Anna Romanova dives into exactly that. How do we build a rule book for robots that they can, actually understand and follow?
Right, so this is the heart of the problem. Think about our legal system. It's packed with words like reasonable or in good faith. And that's totally on purpose, right? It leaves room for human judgment and context. But an AI, it doesn't do judgment. It needs cold, hard mathematical instructions. So how in the world do you translate our wonderfully fuzzy human laws for a machine that literally thinks in ones and zeros?
This isn't some newfangled idea that just popped up. This dream of turning our often ambiguous legal language into something a machine can just execute, what people call computational law, it's been around for a long, long time. The big difference now? We are getting incredibly close to making it a reality. Just imagine a contract that's basically an algorithm a computer can simply run, no lawyers needed. And let me be clear, this is not just some theoretical what-if scenario. Let's look at something that's already happening. AI in the corporate boardroom. I'm not kidding. A venture capital firm has actually appointed an algorithm to its board of directors. All of a sudden, this isn't some academic debate anymore. It's a very real challenge we are facing today.
And this really gets to the core conflict. The paper makes this fantastic point. Human decisions are what you'd call social constructs. They depend on shared culture, context, intuition, all that messy human stuff. But AI decisions? They're technical constructs. They are all about pure logic and data. And that's exactly why you can't just hand an AI a legal textbook and say, go figure it out. They are speaking two completely different languages.
So where do we even begin to look for a solution? Well, it turns out we can take a cue from a field that's been grappling with this exact same problem for years now, self-driving cars. I mean, they have to navigate our chaotic, unpredictable human world, all while following a very strict set of rules.
And the key concept they use is something called the Operational Design Domain, or ODD for short. Honestly, the best way to think about it is like a super specific instruction manual for the AI. The goal isn't to teach the car to drive absolutely everywhere. No, the goal is to define the exact conditions where it can operate perfectly and, most importantly, safely. I look at how specific this gets. An ODD for a car might say something like, okay, I only work on highways. I do not work in the snow. My speed limit is 70 miles per hour, and I only operate during the daytime. See? It's not about being able to do everything. It's about having a crystal clear, unambiguous set of boundaries. And this is the absolute crucial takeaway from that analogy. That promise of perfect safety, it only holds up as long as the AI stays inside its defined box. The second it ventures outside those predefined boundaries, well, all bets are off. And this idea, this defined, safe, operational space, is exactly what we need to bring over to the legal world. So the big question is, how do we take this idea of a defined box from the world of engineering and apply it to something as abstract and nuanced as corporate law? Well, this is where the paper lays out its really clever core solution, the official rulebook for robots. The paper's solution is actually and brilliantly simple, a dual document approach. Instead of trying to force one set of rules to fit both humans and machines, you just create two. The humans get to keep their familiar corporate charter with all its broad, interpretable principles, but the AI, it gets its own separate document, one that's machine-readable and filled with precise, verifiable algorithms. And the paper has this perfect analogy for it. Think of a bilingual legal contract. You see this all the time in international business, where a contract is written in both English and Chinese, for example. It's the exact same agreement, it's just expressed in two different languages for the two different parties. That is precisely the idea here. One set of rules translated for both humans and AI. Okay, that sounds really elegant in theory, but what does this translation actually look like in the real world? Let's take a standard rule from the world of corporate governance and see how we'd actually build a version for an AI. Here's a perfect example. A human board member is told they have to ensure fair treatment for all shareholders. We all kind of get the spirit of that, right? It's about ethics, it's about not playing favorites. But how on earth do you explain the concept of fairness to a machine that only understands data and logic? And this is how it works. The human principle, the why, is basically be fair. But the AI's instructions, the how, become a concrete checklist. So instead of fairness, the AI is explicitly told, run quarterly bias audits on these datasets, disclose all of your decision-making parameters, and only use these specific, pre-approved algorithms for allocating resources. You see? It turns an abstract idea into a concrete, measurable, and auditable set of tasks.
Let's take another one. A huge part of any board's job is just monitoring the company's performance. For a human, that means reading reports, asking tough questions in meetings, and using their gut intuition.
But for an AI, you can transform this duty into something incredibly powerful. You can give the job of continuous monitoring. You give it a very specific list of data sources to watch. It watches them 24/7 in real time, and it can flag a potential problem the very instant it happens. I mean, that's a level of oversight a human board could only ever dream of having.
So, this all leads us to a final, really powerful analogy that ties this whole idea together beautifully. It asks us to think about a fundamental question. Is an AI on a corporate board more like a car on a public road, or is it something else entirely?
Okay, get this. If you look at the data, it shows that cars, which have to operate in our messy, chaotic, unpredictable world, are way, way riskier than trains or airplanes. And that's fascinating, because trains and planes are vastly more powerful and faster. So what gives? What's the big difference? The secret, of course, is their dedicated infrastructure. Trains have their own private railways. Airplanes have controlled air corridors. It's this special, predictable, controlled environment that allows them to unleash their incredible power and speed safely.
And really, that's the fundamental choice we have with AI governance. We can try to force it to work like a car on a public road, trying its best to navigate our messy, unpredictable human world. Or we can build it its own private railway, a dedicated, predictable, safe environment where it can operate at its absolute full potential.
And that, right there, is the real takeaway. This whole dual rulebook system isn't about holding AI back or limiting it. It's the exact opposite. It's about building these specialized tracks that will let these unbelievably powerful systems run safely at full speed. So this leaves us with a pretty massive question to chew on. If this dual document approach works for something as complex as corporate law, where else are we going to need it? As AI becomes a bigger and bigger part of our lives, are we heading for a future where every single major law needs two distinct versions, one written for us humans and another one written for the algorithms that are quietly starting to run our world?